Thanks. Yeah, so I've got the first and only item on the agenda, which is ES Query. And this is a tool that I developed this week or last week, I guess. And it came out of some analysis I wanted to do during a recent incident where I wanted to do some post-processing on data that is stored in Elasticsearch. So our logs are in Elasticsearch, and I wanted to do some local post-processing that is not that easy to do with the Elasticsearch query language. And I also wanted to grab the data so that we have it for longer than the 7-day retention window that we have in Elasticsearch. And I was shocked to discover that there isn't really a good tool that does this kind of thing, like grab, you give it a query, an Elasticsearch query, and get out the JSON data. It just doesn't seem to exist. And so I looked around at some client libraries and developed this tool, which is basically a small Go binary. So just to quickly share the repo, there's some documentation and instructions here in the README, so you can kind of see some of the stuff that this tool is capable of. But I will also give a quick demo. And I did prepare something that hopefully will not include any sensitive information, because we are dealing with our production logs here. So here's a sample query where we're querying the GCP events index. So this includes things like instance maintenance. So it's useful to see if a host was rebooted due to a maintenance event. And so you can give it a query either using this -query parameter, and then you kind of dump the JSON in there. But you can also provide this query on standard in. And so this is particularly useful if you're using Kibana and you've got, like, you use Kibana as a query builder. You've got an Elasticsearch query that you can get from the inspect tab in Kibana. You paste that into a file, and then you'd basically do, cat query.json, extract the query field out of that thing, and then pipe that into ES Query.
And you can also use PV paste even.
True. Yeah. So that's kind of the basic idea. So with that, let me just go ahead and run this. And so and you can see I'm piping into JQ here to kind of extract some not so sensitive information out of these logs, because I think they did include some IP addresses and such, which don't want to include on this recorded call. But this kind of shows what you can do with this tool. And, you know, you can do whatever kind of analysis you want. So you're just looking at how many log lines were present during this time range, which is, you know, a fairly inefficient way of getting that count, but it's very efficient on human time, because it's very easy to put together this kind of query and this kind of pipeline. One last thing that I want to show is you can also give it -verbose to see what it's actually doing. And this is a a custom build that is actually stripping out the password, which we probably want. And that patch is pending upstream in the library to actually strip out those passwords. But with this verbose, you can see, it's actually doing quite a bit of stuff just to paginate through the results. And that's the Elasticsearch pagination API. It is not very curl friendly. So that's why you would want to use this tool in the first place over, basic curl commands. So yeah, that's basically it.
Cool.
Any questions, thoughts, comments?
I kept thinking the whole time, what's the difference with curl? But you answered that at the end. Yeah, that's it's annoying having to do pagination.
Yeah, it's not even that. There was a couple of deletes in there for some cursor as part of the requests. So you really don't want to be manually remembering
yeah,
where am I in this chain of API calls that I need to do a delete instead of a get next.
Yeah, it's kind of obnoxious. So you do like a normal search call, but then you give it a scroll parameter and you say how long you want this scroll to exist. And it'll create this scroll object, which does expire after whatever timeout you gave it. And then you need to go to the scroll API and say, this is the scroll ID from the last call. Please give me some new results and a new scroll ID. And so that's kind of how you paginate through. So you need to kind of keep getting the token from the last response and piping it through to the next one. Pretty obnoxious to do with curl. And then to be nice, I kind of delete those at the end. In this case, we could also wait for 1 minute and they'll clean themselves up. So that is not strictly necessary, but it's nice to clean up after yourself.
Sorry, I was unmuted.
And also, this tool has already been pretty useful for some other use cases. A recent one was introducing new log fields and introducing those conditionally. So this is the feature flags, actually. So we kind of, in Rails, log which feature flags were checked as part of that request and whether the result was true or false. And there's a lot of interesting stuff that you can do with that data, but one of the concerns I had was that this would massively increase our log volume in terms of the size of the log lines. And Elasticsearch doesn't store the size of the source object anywhere. You'd have to kind of compute and store that on your own if you wanted to really query that or get that out of Elasticsearch. And so with this tool, I could, query a sample and run my own statistics as a Unix pipe on that. Yeah,
there are quite a few aggregations I've wanted to do where, you can use the JSON objects directly to aggregate. So you can run a function on all of those, but that's not very convenient sometimes if you want to do something complicated and every time you do it, it's going to have to refetch everything and recompute it. And especially if it doesn't really fit into that processor document at a time model, it's also challenging. So yeah, that sounds good.
Maybe I could talk a little.
Yeah.
Thanks. Maybe I can talk a little about the patch I submitted to the Git mailing list, because it ended up being getting progressively more boring, which is good. And I'm still waiting to hear more, but it's looking good. So let's see. I can show it as a merge request on our mirror of Git. Oh, this is not it. This is a stock mirror, last update 3 months ago. But this is also a mirror, and this has merge requests. And the problem I'm trying to solve is that the IO sizes we use when transferring backfile data are not optimal. This is a typical thing. If you do IO, then you can tune the IO sizes, so the size of the chunks of data you send across something. And sometimes it's irrelevant and sometimes it matters. And we send so much data, so much backfile data, that it matters, apparently. And so, yeah, but we had to come up with we had to figure out how to solve the problem. And I got feedback from Patrick from the GitLab team, and we came up with something where actually this was my first idea, was to use standard IO. So then I had to wait, let me use the file browser here. I had to make some changes in upload pack so that it uses standard IO. And I had to create another function that uses standard IO instead of regular Unix syscalls. And because the standard IO buffer size is not that big, just using standard IO on its own is not enough to get larger writes. I also had to create a configuration mechanism with an envar to have a larger buffer. And this is also iffy, because if you want to reconfigure the buffer, you want to do it as early as possible in the process lifecycle. So the common main is, or this happens in a function. Yeah, this is really the main function of all Git subcommands. I learned in a previous attempt that that is the right place to do it, but it also makes it harder to sell if you're adding stuff to the main startup function of that affects everything. So yeah, that was 74 lines. But then I was going back and forth with Patrick, and I was trying to write a cover letter for the Git mailing list, and I realized, like, I'm asking for more than what we actually need, and there's something simpler we can do, which is in somewhere in the diff here. I could say, well, there already is a buffer that's used for the copying, and right now it is 8 kilobytes plus 1 byte. So what if we can just configure that? And it's okay to compile in a different size, because we compile Git when we build Gitly. So we have our own Git anyway, so we can use a different number here. And this is actually better than just tweaking the write sizes, because this also makes the reads bigger. So it saves even more time. So I thought, okay, but yeah, then we have a new compile time constant. Do people like that? Well, let's just try. And then the funny thing on the Git mailing list was that they said, well, why don't we just make this buffer bigger and forget about the constant? And that didn't even occur to me, because nobody who's not using the back objects, everybody who's not using the back objects cache is probably going to doing 8 kilobyte writes. So they don't benefit from making this buffer bigger. But the Git maintainer said, why don't we make the buffer bigger? And that's actually the simplest thing to do. And so, well, it would have been it would have been nice if it was just this one line that got that where I changed the number. But the line is funny because the calculation of the number is weird. So I wrote a comment to explain the calculation. And then people pointed out that allocating 64 kilobytes in a stack variable is a bit much, depending on the platform. So I had to switch it to use heap allocation. So calloc gives you a zeroed piece of memory, because before we also got a zeroed struct. But so the patch ended up very small. And the other nice thing is that I've been doing experiments to compare these things, where I start a flame graph and I do a clone from on the VM where I know it's a cache hit, and then I just count the number of samples in the different programs, and I can say, well, if Git is using 200 samples without this tweak and it's using 120 samples with this tweak, then that is less CPU. And then I add that up. So I look at the Gitly hooks, Gitly and Git samples. Let me just show what that looks like. I don't remember which one this is, but here I'm actually doing something else.
I think you might also be able to get the sort of proportional CPU time from the R usage metrics that we have in logs.
Yes, but Gitly itself is part of it, and that won't show in our usage.
True.
That has been actually a recurring theme in all this work that we've been doing here, is that Gitly itself is a problem, and Gitly cannot measure itself. So what I was trying to say is that my approach has been make a flame graph and add up the different parts that I care about, and then I can make comparisons of the number of samples. But what one of the Git maintainers did was that he just simulated our cache by creating a shell script that gets a pack file, and he measured the throughput on that, and he got roughly the same kind of like 30% kind speed increase. So I got a 30% drop in CPU frames or stack frames. That's also good. And he got a 30% roughly CPU megabyte per second increase when he tried this. So that was a really different way to approach but also a very sensible and valid way to approach the impact. So it was nice to see that it had an impact. And it was really nice that this person took the time to set up that experiment because he was interested. So yeah, the patch got very small. I think it got a good reception, and now it needs to go through the process of the Git maintainer, the Git development process, where the BDFL of Git has a queue of patches he will look at, and he once a week he posts an update to say what the status is of all these patches. So my patch will start being mentioned in what's cooking in Git, which is a weekly email, and then I can keep an eye on the what's cooking in Git email, and at some point it will say it is in the next branch, and that is our internal goal post. Like if once a commit is in next, it is okay, the Gitly team will accept it as a custom Git patch on their build. So once it's in next, I can accelerate it a little bit. And otherwise you wait until next becomes the current Git version, but that's once a month or something of that order. So it's maybe 2. Yeah. Sorry, didn't prepare this, so I was rambling a bit. Any questions or comments?
That's great. I mean, also thanks for sharing a little bit about the development process of Git itself. That part was really interesting to me.
Yeah, it's quite unusual because it's all actually, I don't know, it's unusual compared to what we do. They don't use anything like GitLab or GitHub. It's pure email-based workflow, and everything goes through a single person. So you have maintainers who, I guess what in the Linux kernel community would be the lieutenant role, where they actually not quite. I think with Linux, once certain people have reviewed it, Linus Torvalds doesn't really look at it, or he just accepts big chunks of work that other people have reviewed. But here, the benevolent dictator reads everything. So people go back and forth and make sure that things are in decent shape, but then he has to read everything. Yeah. But it works. Changes get made, things get merged. Yeah. Thanks.
Cool. Thanks, everyone. I'll upload this shortly. Bye. Have a good one.